Hi, I'm Luke from Weldpro. Today I'm here with part 3 of the TIG 200 series. In today's episode, we're going to show you how to set up the TIG 200 and a few other assorted things needed to get welding. I'm going to show you how to prepare your plates and your tungsten to achieve the highest quality weld with TIG. Throughout the rest of this series, we're going to teach you how to weld mild steel, stainless, aluminum, out of position welding, and even pipe, and that'll all come with time. But for now, we're going to start with fusion welding, sometimes known as autogenous welding. Before we get started setting up the machine, let me show you how to grind tungsten. When grinding tungsten, it's important to get a nice symmetrical cone. We're going to put our tungsten against a grinding wheel and we're going to twist it. One very important thing to note, don't grind the taper on your tungsten more than 1.5 times the diameter of the tungsten. If you have a very long point, under high current conditions, the tip of the tungsten can fall off due to erosion and land in your weld pool, causing contamination. The best way to achieve a perfect cone on this tungsten is to insert the tungsten into the chuck of a drill. Going slowly, you'll spin the drill as the tungsten is grinding. This will help achieve that perfect symmetrical taper that we're looking for. If you don't have a drill, that's okay. You can spin the tungsten with your fingers. It's just very hard to achieve that perfect cone. Often it will leave a flat spot or create an elliptical shape on that cone. When grinding tungsten, always wear safety glasses. It doesn't take much for a piece of this extremely hard tungsten to come flying off and head directly into your eye. Okay, so I've gone ahead and inserted the tungsten into the chuck of my drill. I'm going to turn on the grinder and I'm going to start to grind this taper on very slowly. Positioning your tungsten on the wheel correctly is important. If your tungsten is too high, your taper will be too long. If your tungsten is too far down on the wheel, you'll just be grinding a flat spot or a very short taper. This will come with practice. Alright, when ground correctly, your tungsten will have a nice symmetrical point that's no longer than 1.5 times the diameter of the tungsten. Once you've ground your tungsten, go ahead and pick up your TIG torch. You'll want to slide in your tungsten painted end first. It goes in the end of the gas cup into the collet body. Now that your tungsten is inserted into your torch, we need to talk about the tungsten stick out at the end of the gas cup. At no point should the tungsten stick out further than the diameter of the gas cup. This can cause porosity along with other weld contaminants. It can also erode and contaminate your tungsten very quickly. I'm going to be working on a flat piece of mild steel today. Therefore, I'm going to keep my tungsten a little closer. This will help ensure adequate gas coverage. When you have your tungsten recessed exactly where you want it, go ahead and tighten this back cap. This will secure the tungsten through the collet and the collet body. The next step in the process is to turn on our shielding gas and to set our flow meter accordingly. I prefer to wear safety glasses when I open high pressure tanks. I do this because I've had some encounters with older flow meters and regulators that upon cracking that high pressure tank will actually fail and can explode. Before we open our tank, we want to make sure that our flow meter is in the vertical position. This will ensure accuracy of the flow meter ball. I also prefer to open a tank with the gauge pointed away from me. If a regulator or a flow meter were to fail, typically that would happen at the gauge. By pointing this gauge away from yourself, if this regulator were to fail, debris would fly in a direction away from you. And last but not least, when we go to open the valve, we want to do so very slowly. If you were to open this valve rapidly, it would shock the flow meter and the gauge. Let's go ahead and crack the valve now. We're going to do so very slowly and we're going to watch the pressure gauge climb to its peak point. After slowly cracking our valve, we're going to go ahead and turn that valve counterclockwise all the way until the tank is completely open. High pressure tanks use a double seat system. There is a seal on the top and the bottom of this valve. When the valve is closed, the tank is sealed off by this bottom seal. When you crack your valve, there's a pin inside that raises to allow the gas to flow through. When unscrewing this valve, it's important that this top seal backs all the way against its seat so that none of the gas from the argon cylinder travels up through the top of the valve and leaks from the seal. This will save you from wasting a lot of argon shielding gas. A good habit to get into is after you've opened your valve, turn it back off. You can wait a few minutes, watch your pressure gauge. If the pressure gauge drops, you have a leak somewhere. If the pressure holds fast, you'll know you did a great job tightening everything down. If you do experience a leak when you're first hooking this up, the most common place that this happens is right here off the flow meter on this coupler. The flow meter coupler uses a ball and socket design on one end where the hose connects. It uses standard brass threads on the other end where it connects to the flow meter. You may find a little gas leaking out of the top of this coupler. One other way to see if you have a gas leak in one particular place is to spray some Windex or just some soapy water on this coupler. If there's a leak at all, you'll see bubbles coming out of it. The best thing you can do when installing your flow meter is just put some Teflon tape on that top coupler threading. Make sure that you don't use any Teflon tape on any of the other connections. They're a ball and socket design. Ball and sockets are designed to seal themselves without using any tape. Now that we're sure we don't have a gas leak, I'm going to go ahead and slowly open my cylinder again. And once again, go ahead and unscrew that counterclockwise all the way to backseat your valve. Now I'd like to take a few minutes and talk about setting up the interface on the welder. Go ahead and turn your power switch on the back of the machine. Now, if your machine is set to MMA mode, you'll need to hit this button in the upper left corner to switch to TIG mode. If your machine is currently in AC mode, hit this button to alternate between AC and DC. AC current is primarily used for welding aluminum. For the mild steel we're going to be welding with, we need DC current. When you hit the menu button, you'll notice one of these red LEDs lighting up in the center section. This is an indicator of what setting you're currently adjusting. You'll notice there are two menu buttons, one on the right-hand side and one on the left-hand side. If you use the one on the left-hand side, it will cause the indicator to move to the left. If you use the one on the right side, it'll go to the right. Let's move our indicator light all the way over to the left where it says pre-flow. Pre-flow time is the amount of time that your argon shielding gas will flow from your gas cup prior to the high frequency arc starting. The reason we use a pre-flow is so we can get some shielding gas around our tungsten and around the plate where we're going to weld prior to striking our arc. If we strike our arc and there's no shielding gas around, it could immediately contaminate the tungsten. Your pre-flow time is adjusted in seconds. We're going to set this with the dial now. You don't need too much pre-flow time or it's a waste of gas and a waste of time. I prefer 0.2 or 0.3 seconds. The next indicator to light up is the starting amperage. This will be the amperage that's output by the machine when your foot pedal is at its lowest point. You typically want this set as low as possible, so when you first push your pedal, you're not blasting a 200 amp arc directly into your plate. We're going to talk a little more about upslope and downslope when we start talking about the trigger switch, so watch out for that video. For standard welding processes, make sure that your upslope and your downslope are set to 0. This is very important. The next indicator you'll see come on is the peak amperage. This is the maximum current the machine will output when your foot pedal is pressed all the way down. Where you set this has a lot to do with preference and the particular project you're working on. But as a general rule of thumb, I like to start around 120 amps. If I max out my pedal at 120 amps and I'm not achieving the weld pool I like, I can always increase this. By toggling menu right again, we'll see the end amperage. As we bring our current down, as we back off the foot pedal, we want our arc to come down slowly. We want to maintain a very low current arc at the end of our weld and then extinguish it in a particular way so to not get weld cracking. The last setting on the menu is post flow. Similar to pre-flow, post-flow allows gas to flow after the arc has been extinguished. Post-flow is very important. It takes time for the tungsten and the weld pool to cool down. If your gas were to shut off the instant the arc was extinguished, it's likely that you would see weld contamination or tungsten contamination. Post-flow has a lot to do with the type of material you're welding and some personal preference. For now, I'm going to set mine to 3.5 seconds. I'll show you why later in the welding process. There are a few more settings that we can adjust on this interface when we're working with pulse TIG. We're not going to cover any of the pulse settings today. Pulse can be very nuanced, and we're going to do a video specifically on that, so keep an eye out. In the bottom left corner of the interface, you're going to see a button that says 2T and 4T. For now, set that to 2T. This will be the preferred welding method. Today, I've prepared 2 1/8-inch plates. I've cut them 2 inches wide. You'll notice that one of these plates is shiny and one is dull looking. This type of steel is known as hot rolled steel. When steel is hot rolled, it's left with a mill scale coating on the surface. This mill scale coating will often peel up immediately and contaminate your tungsten when you begin welding. It's very important that you grind the surface of your plate so all the mill scale is gone. The cleaner the workpiece with TIG, the better you'll be, I promise. Now, a couple things in the way of safety before we get started welding. Number one, you always want to wear safety glasses. Just as any experienced welder, slag and debris finds a way to get in your eye no matter what. You'll want to make sure you have a welding jacket or a long sleeve cotton shirt. The reason we choose cotton is because it's naturally flame resistant. If you're wearing something that's spandex or lycra and a piece of hot steel lands on it, it will melt and often melt directly into your skin. Cotton doesn't do that, so it's the preferred material to weld with. Leather jackets are typically preferred by people who are running stick, flux core, MIG. Those types of processes emit lots of sparks and slag. Those sparks will quickly burn through a shirt. For TIG welding, I prefer a heavy-duty long-sleeve cotton shirt. Ideally, when you're running TIG, you shouldn't have any sparks spraying around. So without further ado, let me get changed and we'll get to welding. It may go without saying, but it's important that when you're welding, you have eye and face protection. Don't ever try to weld without a welding hood with a lens in it. There are many different lens shade options. For TIG, I prefer a shade 9. 9 is a little on the brighter side, so I like that for TIG because I can see all the nuances of my weld and my weld pool. Make sure that you have no exposed skin. It won't take long to get a pretty severe sunburn. Make sure that your ground clamp is securely connected. Typically, most people prefer to hold the torch handle like a pencil. There are times when you'll want to grip it, but most of the time, holding it like a pencil will allow you to finesse your arc the way you want. What we're going to do is get our tungsten very close to our plate, preferably within 1/8 of an inch. We don't want to get too close to the plate, or when you hit the foot pedal, the tungsten will stick to the plate. Once we press down on our foot pedal to start our arc, we'll increase our amperage ever so gently until a weld pool develops, the size that we want. Once the weld pool becomes established, you'll want to begin traveling. We travel in a leading direction, meaning there is a backwards angle to our torch. It's important that that travel angle not be more than about 5 to 15 degrees off center. If you have your torch like this, the gas is flowing out of the end of the cup. It can easily draw air in with it. This can create weld contamination. The last thing we need to check before we start welding is our gas flow rate. What you want to do is give the pedal a gentle tap. This will start the flow of gas through the flow meter and allow you to see what type of gas flow you have. My current flow rate is set at about 20 cubic feet an hour. That's a little high for me, so using this small dial, I'm going to adjust that down to 15. Now we're ready to go, and we know we won't be wasting excess shielding gas. I want to tack weld my piece to my table. This way it doesn't slide around while I'm working on it. I'll I'll do this by starting my arc, gently increasing my amperage, and melting a small corner of my plate into the table. I'm going to go ahead and push down on my foot pedal to establish my high frequency start. Okay, with the pedal slightly depressed, we're probably running about 5 amps. Let's increase that ever so slowly until we see our plate begin to melt. Now, you'll notice when I'm done welding, I leave my gas cup in position and allow my gas to post-flow to protect my cooling weld pool. Using the edge of my plate in my peripheral welding vision, I'm going to guide myself across and run one straight fusion weld across my mild steel plate. We're not going to focus on filler material just yet. We're going to get to that in part 4. Okay, I'm ready to lower my hood and run my fusion weld across the entire length of my plate. Okay, I'm going to go ahead and establish the arc about 1/4 inch inside my plate. I'm going to slowly increase my amperage to develop a weld pool. You can begin seeing that little weld pool forming. Now, we can travel in a straight direction across this plate. Watch your weld pool. You don't want to have too fast of a travel speed. If you like, you can do a little manipulation technique. I personally prefer a little bit of a circular motion. If you've done this correctly, your weld should come out looking something like this. Now, go ahead and repeat this over and over, making pass after pass. This will help you work on muscle memory, torch angle, and travel speed. Let's say you're welding along real nicely, and all of a sudden you accidentally touch your workpiece. Blah. Oh no, our TIG torch is stuck to our workpiece. How do we get it off? The beauty of tungsten is it's very brittle. So go ahead, give your TIG torch a few seconds to cool, and then wiggle it left and right gently. The tungsten should come off. Okay, since I stuck my tungsten, a couple of things have happened. Number one, I got my base material on my tungsten. So now the end of the tungsten is contaminated, and you can see there's a bunch of metal on it. The second thing that happened is the very tip of my tungsten is gone. It's in the weld pool. I can see it. Tungsten is an extremely hard substance. You will not be able to weld over a chunk of tungsten and expect to get it to come out of your weld pool. You must remove it with a grinder. A general rule of thumb is anytime you stick your tungsten, you need to grind that spot back out very well. Now that we have our workpiece cleaned back off, we need to fix our tungsten. Loosen your back cap and slide the tungsten out of the TIG torch. Trying to cut this tungsten is very, very difficult. The easiest way to get the contaminated tip off of the tungsten is to break it off. You can do this using a vise, a pair of vise grips, or just the edge of a hard surface. While holding your tungsten over the squared, hard edge of a surface, take a hammer or another heavy piece of steel and tap the tip of the tungsten. It should snap right off. Okay, you'll see we have a new square edge on our tungsten. We're ready to grind one more time. All right, now that I've reground my tungsten, I'm going to go ahead and slide it back into my torch. Let's go ahead and finish up that pass where we stuck our tungsten. We'll tie into the spot where we just ground out. get to the end of my weld, going to slowly back off of the current, allow the arc to settle down, extinguish, and allow my 3.5 second post flow. After running several passes on this practice plate, it should come out looking something like this. Now I've stepped my welds back just a hair so you can see how I overlap them. Thanks so much for watching this video. Hopefully it helped you out. If you have any comments or questions, feel free to leave them below. Most importantly, hit that subscribe button. Weldpro is committed to releasing lots of tutorial and how-to videos that are going to help you be successful. So be a part of that. Subscribe to our channel. From all of us here at Weldpro, thank you so much for tuning in. We can't wait to see what you build with your TIG welder.